Okay, this is section 4.2. We're going to be graphing linear equations. Okay, what do we know about the word linear? Well, what comes to mind for me is line, straight, a line never ends. Now, one of the things we have to be careful of is when we do our graph on the coordinate plane, we have to be sure that we place arrows on the end because these arrows indicate that the graph never ends. If you don't put the arrows on the end, you're just drawing a line segment, and that's not the same thing. So a line consists of infinitely many points, x and y. So what we're going to do is we're going to verify whether or not a point is on the line. We've done this before. So a point is a solution if the end statement is true, and a point is not a solution if the end statement is false. So let's take a look at this one. We want to decide whether the point is on the graph of the line x plus 3y is equal to 6, and we have the point 1, 2. So I plot my point 1, 2, and it doesn't appear like it's on the line. So we're going to verify algebraically. Now we know that in the coordinate points, they are x, y. So 1 is my x value. I'm going to plug that in for x. 2 is my y value, and I'm going to plug that in for y. So I get 1 plus 3 times 2 gives me 6 is equal to 6. 1 plus 6 gives me 7. Okay, is 7 equal to 6? No, the statement is false, so 1, 2 is not a solution. Now we're going to decide whether the point is it's on the line of the graph of x plus 3y is equal to 6. This time we're looking at the point negative 3, positive 3. So go from negative 3 up to positive 3. It looks like it is. So in those earlier lessons, what we were doing when we verified if a point was a solution or not is we were actually seeing if it was on the line. So now, again, we're going to plug this in. Negative 3 is x, positive 3 is y. So I end up with negative 3 plus 3 times 3 is equal to 6. Negative 3 plus 9. Negative 3 plus 9 gives me a positive 6. 6 is equal to 6, so this statement is true, and negative 3, positive 3 is a solution. Now when we're graphing a line, there are 4 steps that we have to do. And the good thing is none of these steps are anything new to us. The only thing that's different is we're doing them all in the same problem. We're going to write the equation in function form. That just means, hey, solve for y. The next thing we're going to do is we're going to set up a table and we're going to choose 3 or 4 points for x. We're choosing these points. Then we're going to plug the x values into the equation and we're going to find out what y is. Now after we do that, we have an x and a y, so we're going to plot and then we're going to connect the points. So now we're going to use the table and we're going to graph 3x plus 2y is equal to 1. The first thing we have to do is we have to solve for y. Now I have 3x plus 2y is equal to 1. Well, I need to subtract 3x from both sides. 1 minus 3x, there's nothing I can do with that because they are not like terms. Now I have 2y is equal to negative 3x plus 1. Well, y is still not by itself. I need to divide both sides by 2. What I'm going to do is I'm going to divide each term by 2. It's going to make it a little easier for me later on. So now I have y is equal to negative 3 halves x plus 1 half. So now we're going to just choose some values for x. Now I'm looking at this and I see that my coefficient is a fraction. I want that 2 to cancel out. Well, I'm going to choose multiple of 2's. So I'm going to choose a positive 2. So I've got y is equal to negative 3 halves times 2, plug that in for x, plus 1/2. Negative times a positive is going to give me a negative. My 2's cancel. Now I have negative 3 plus 1/2. So now I have negative 3 plus 1/2. I'm going to take the small number from the large number and keep the sign of the large. So 3 minus 1/2 is going to give me 2.5. 3 is larger, so it's negative. So my point is 2, comma, negative 2.5. My next point, one of my favorite points to use for x. Remember, you can use absolutely any point that you want. I'm going to use 0. I have y is equal to negative 3/2 times 0 plus 1/2. Well, negative 3/2 times 0, oh, well, that's just 0. 0 plus 1/2 gives me 1/2. So my point is the point 0, 0.5. Okay, the next one. I'm going to try negative 2. So I have y is equal to negative 3/2 times negative 2 plus 1/2. Okay, now I've got a negative times a negative, so I know that's going to give me a positive. So now I have positive 3 plus 1/2. So that's going to give me 3.5, and I have the point negative 2, 3.5. Now what I would recommend that you do is when you're choosing your values for x, I recommend that you put them in a numerical order, either from highest to lowest, lowest to highest. Put them in some kind of order. Now we're going to go through and we're going to plot our points. First, I've got the point 2 and negative 2.5. Now I have 0 and 0.5. And now I have negative 2 and 3.5. Okay, very important. Take your straight edge and connect the lines. You will know that you've made a mistake if your straight edge won't cover all 3 lines at the same time, all 3 points at the same time. So your line that you draw should go through all 3 of your points. Remember to put your arrows on the end, and that's it. Okay, now let's take a look at another example. I've got y equals negative 1/2 x plus 2. Okay, good, it's already solved for y, so I don't have to do that. Now I just have to choose my values for x. Now, I see I've got another fraction. So what I'm going to do is I'm going to choose multiples of 2 and probably a 0 for my x values. So I'm going to start with a negative 2. So now I have y is equal to negative 1/2. X is negative 2. Then plus 2. Negative 1/2 times negative 2 gives me a positive 1. Positive 1 plus 2 is 3. So I have the point negative 2, positive 3. You have to be very careful to follow the order of operations. Okay, now I'm going to use 0. So y is equal to negative 1/2 times 0 plus 2. Negative 1/2 times 0 gives me 0. 0 plus 2 gives me 2. So my coordinate's going to be the point 0, 2. See, next I'm going to use positive 2. So y is equal to negative 1/2 times positive 2 plus 2. A negative times a positive is going to give me a negative. Negative 1 plus 2 is going to give me 1. So now I have the point 2, 1. Notice the pattern, 3, 2, 1. And I have this pattern because I went -2 plus 2 gives me 0, 0 plus 2 gives me 2, so that it helps me develop a nice pattern. So now, the point -2, 3, the point 0, 2, and the point 2, 1. Get my straight edge, connect these guys together. Remember to put my arrow on the end, and there's my graph. Okay, now the last thing we're going to look at are special lines. That's when we have y is equal to just a plain number or x is equal to just a plain old number. So the first thing we're going to do is we're going to look at y equals 3. We're going to graph this one in blue. So when I see this, I could do the chart if I wanted to, but I think the chart just makes it more confusing. So I've got y equals 3, so I'm going to go on the y-axis, and I'm going to go to the 3. And I need to draw a line that only crosses the y-axis, doesn't cross x at all. So in order for it to not cross x, it has to be parallel to x. So I'm going to draw a horizontal line that goes through the point 3 on the y-axis. Now I've got x is equal to -4. Draw this one in pink. Well, now I've got x is equal to a number, so I'm going to go on the x-axis. I'm going to go to -4, and there's only one way that I can draw a line that only goes through the x-axis, doesn't go through y, and goes through the point -4. For this one, I'm going to draw a vertical line. And that's all there is to it. This is one of the easiest graphs that we have, but it's one of those I think it's so easy that people don't spend any time on it. Practice this and make sure you're comfortable with it.